Good day, everyone! Welcome to our channel. For today's episode, we will be learning a new topic in logic and set theory. By the way, I am teacher Famela Sora.
I am teacher Daniela Ebol.
And I am teacher Faith Roa.
Have fun and learn!
Hey class, before we are going to start the discussion, please all rise. Class President of the class, kindly lead the prayer. Amen. Good morning class, how are you today? Do you know the trend, put a finger down? Okay, raise your right hand and shake your fingers. Just put a finger down if you feel what I'm going to say. Understood? Put a finger down if you are happy today. Put a finger down if you wake up early. Put a finger down if you are in love. And put a finger down if you are excited to go to school. And put a finger down if you want to learn something. That's good to know, class, that you are at present and okay. Before you are going to sit properly, kindly pick up pieces of paper under your chair and arrange your chairs properly.
Class secretary, who are the absentees for today? Very good. It is nice to hear that. So, before we proceed to our discussion, I want us to have an agreement so that we will have a well-organized discussion. So, these are my classroom rules. First, do not answer in chorus. If you want to answer, raise your hand. Listen to the person who's talking in front and answering. Respect each other. Are we clear? Very good. What was our last topic? Okay, Ma'am Tano. Very good. Again, what is a set? Okay, Viola. Very well said. What are the two types of subset? Tunggol? Yes, very good. So, are we clear about set and its type? Any question? Class, before we are going to proceed in our proper discussion, we will having an activity that is entitled 4 pics and 1 word. Are you familiar with this game? So I will be presenting a pictures and you will guess what's shown in that picture. In this game, there are 4 pictures that will flash on the projector and you're going to discuss a 1 word that describes the 4 pictures shown. The first group to answer will gain points. Do you understand? Great, let's start. Count up from 1 to 3. All number 1 at the first row, and all number 2 at the second row, and number 3 at the third row. The number of your group will be your group name. Okay? Do you understand? Go to your group quietly. Are you ready, class? The game will start. There will be 4 sets of pictures. The first set is, yes, group 1. Yes, very good. That is order. This next. Okay, group 2. What is it? Yes, very good. The word is set. Next. Okay, group 3. The word is infinity. You got the correct answer. Okay, next. The last one. Okay, group 1. Yes, that is correct. The answer is round. And that is the end of our activity. Okay, good job everyone. Let's give ourselves an amazing clap. 1, 2, 3. 1, 2, 3. Zing, zing, zing. Amazing. Now, what do you think our topic today? Thank you for answering. Now, let's welcome Teacher Famela for discussing the new topic.
Hello everyone! This is again Teacher Famela, and now we'll be tackling the new lesson in logic and set theory, which is entitled X ordering and ordinal numbers. For today's discussion, these are our objectives. At the end of the lesson, the learner can first define and use ordinal numbers. Second, discuss the concept of ordinal numbers in set. Third, create set construction with ordinal sets. And lastly, apply ordinal numbers to represent well-ordered set. So I hope that at the end of the lesson, we will be able to meet these four objectives. Class, now for us to understand our topic well, let's have first an activity. Are you ready? Again, are you ready? Okay, I guess you are ready and excited. Now, I will group you into 7 groups. Okay, count up from 1 to 7. All number 1 will stay here. Number 2, number 3, number 4, number 5, number 6, and number 7. Are you now in your group? Okay, that's great. This activity is called Ordinal Constructing or Ordinal Number Set Building Challenge. Okay, each group will receive an index card. So these cards have different ordinal numbers written on them, and take a look and familiarize with your assigned numbers. Did you get it? Okay, in the center of the room, you will find a variety of objects or pictures. This represents the building blocks for our sets. Exciting, right? I know, it's very exciting. Here's the challenge. Using ordinal numbers on your cards, build sets of objects. For example, create a set with the first, second, and third items in the sequence. Am I clear? That's just an example. Am I clear? Again, did you understand? Okay, great. So this time, I will be giving you these cards. Okay, group 1, group 2, group 3, group 4, group 5, group 6, group 7. Now, Teacher Fam will be setting the timer for 15 minutes. Work together to arrange your objects on the whiteboard according to your ordinal numbers. All things are set? For you to be guided, this is our rubrics. Correctness of answer, 15 points. Presentation, 10 points. Cooperation with your group, 5 points. And timeliness, 5 points. That is a total of 35 points. Understand? Any questions? Any clarifications? Did you get it? Okay, that's right. Class, your timer starts now. Okay class, time is up. Each group will now present their sets to the class and discuss what did they notice in each other's sets. Okay, let's start with the group 1, followed by group 2, group 3, 4, 5, 6, and 7. Class, thank you for your very good presentation. Job well done, and you are able to do the activity correctly. Since we are done with the activity, let's proceed now to the proper discussion of our topic. Let's define first what is ordinal. Okay, ordinal is a transitive set that is well ordered by the membership relation. Okay, when we say transitive, it means that every element of the set is also a subset of the set. And when we say well-ordered from the given definition, it means that every non-empty subset has a least element. Okay, ordinals are often denoted by a Greek letters such that A, which is read as alpha, beta, and Y, and etc. For example, the ordinal 0 is defined as the empty set, which is denoted by this sign. The ordinal 1 is denoted by this, and as well as the ordinal 2. So as you can notice, Okay, from the given example, 0 only has a 1 null set and it is not included by a curly braces. And the ordinal 1 is a null set inside the curly braces, and the ordinal 2, it has 2 null set and it is inside the curly braces. One from a curly braces and another one inside a curly braces, as you can notice.
This is what it exactly looked like from the given example.
Now, these are the properties of ordinals. Okay, first property, transitivity. If A is an ordinal or alpha, then every element of A is also a subset of A. Second property, well-ordering. Okay, the membership relation on an ordinal is well-ordering. Okay, the third property is strict set membership. When we say strict set membership, it says that A is an element of B or alpha is an element of beta if and only if A is an element of B not the same as B. Okay, take note of that. Take note of that. That when we say strict set membership, it states that A can only be said that it is an element of B if and only if A is an element of B not the same as B. Did you get it? Okay, let's proceed to the fourth property. Successor ordinal. When we say successor ordinal, it is an ordinal of A defined as A, union, a curly braces or a set of A. As you can notice, A, union, a set of A, which is A is inside now in a curly braces. That is a successor ordinal. And you already know the concept about successor set. Okay, now let's proceed to the limit ordinal. When we say limit ordinal, it is an ordinal that is not the successor of any other ordinal. Is called a limit ordinal. Okay, contrary to the successor set, if the ordinal is not the successor of any other ordinal, therefore it is called a limit ordinal.
So from the given definition, this is the example of successor ordinals. Okay, alpha plus is equals to alpha union set of alpha. So this is the example. 0 is equals to an empty set. 1 is equals to empty set plus is equals to another empty set inside the curly braces, and number 2 is equals to empty set plus is equals to empty set and another empty set inside the curly braces. As you can see from these examples, these are the examples of successor ordinals. So you can see there is a successor from an empty set, then another empty set inside an empty set, and so on and so forth. Below, natural number is one of the example of limit ordinal, wherein it is represented by omega plus. So when we say omega is equals to 0, 1, 2, then infinity or ellipses, then omega plus is equals to omega union omega is equals to 0, 1, 2, ellipses, then omega. So this is the example of limit ordinal. So when we say limit ordinal, as you can see, we cannot notice an empty set there. However, when it comes to successor ordinals, there is an empty set and there is a successor set.
Those are the properties of ordinal. Let's proceed to the von Neumann about the ordinals. So, a set A is an ordinal number or ordinal if it is transitive and well ordered by E or an element. Okay, for the von Neumann, an ordinal is a well-founded set by its definition. Okay, it has an minimal element even without using a foundation. So in particular, A is an element of A for any ordinal A. So we sometimes write greater than sign for the well-ordered E, as it is easier to think of the former relation as an order. Okay, A and B are ordinals. So let A and B ordinals. Okay, first, an element of A is an ordinal. So according to the von Neumann, if we let A and B are ordinals, therefore A or an element of A is an ordinal. Next, an ordinal is equal to the set of all smaller or under E ordinals. So it is said that an ordinal is equal to the set of all smaller under or minimal ordinals. And number 3, a transitive proper that Y is a subset of A is equal to the least element of A minus Y and hence is an ordinal. Okay, number 4. So either A is a subset of B or B is a subset of A. Okay, that's for the von Neumann definition. Number 5, we have A is a subset of B if and only if A is an element of B or A is equal to B. Take note of that. And lastly, we have A is an element of B or B is an element of A. So E strictly totally orders ordinals. So that E corresponds that it is strictly totally orders ordinals. Okay, so that's all for today about our discussion and I hope you learned something. Thank you. And now, to proceed to you about the application and what have you learned from my discussion, let's welcome Teacher Faith.
Hi, I'm Teacher Roa again and I will be giving you another activity based on what Teacher Famela had discussed. Are you ready? Where's the group 1? Alright, how about the group 2? And the group 3? Alright, very good. Are you still in your group? In your group of the 4 picks 1 word activity? Now I want you to select only one representative out of your group for you to be able to pick up the envelope in here for the instructions of our activity. So for group 3, here is your envelope. Group 2 and group 1. Okay. So you only have 10 minutes to complete the task. So for our rubrics, we have correctness of answer, we have 15 points, presentation 10 points, cooperation 5 points, and timeliness 5 points, a total of 35 points. So I'll be asking the class to read on the direction, answer the following activity, select one representative out of your group, and present your answer. So for activity 1, define the term ordinal in the context of set theory. Provide an example of finite and limit ordinal.
For our activity 2, we have ordinal construction. You will work as a group again. Given the set examples of elements X, Y, Z, and W, you will be constructing a corresponding ordinal using von Neumann definition. Do you get it? Alright, let's start. You may stop working now, then paste your output here on the board. Group 1 will be the first to present, followed by Group 2, and then Group 3.
Wow! I guess we all have the correct answer. Clap your hands! So for our activity 1, an ordinal is a transitive set, well ordered by the membership relation. These are the examples of finite ordinal and limit ordinal.
So for activity 2, find the given set of elements X, Y, Z, and W. These are the answers.
Class, our discussion ends here. Any questions? Did you get it? Okay, give yourself 5 claps for a job well done. 1, 2, 3, 4, 5. Okay, class. Since we're now done with our activity, let's now assess your learning. You may get a 1/2 lengthwise piece of paper. These now are the question number 1 and 2, 3 and 4, and 5. For the test 2, you have only 10 minutes to answer.
Now, let's check your answers. For number 1, blank represents the position or order of elements in well-ordered set. The answer is letter B, ordinal numbers. For number 2, what is the correct definition of an ordinal number? What is the answer? Letter B, a number indicating the position or order of an element in a sequence. So now let's proceed to number 3. In set theory, how ordinal numbers contribute to the arrangement of elements? What is your answer? Letter C. They specify the position or order of elements. For number 4, if A is an ordinal and B is an element of A, what can be concluded about B? So what is the answer? Letter D. B is also a subset of A. So for our last number 5, for A and B ordinals, when does A, an element of B, hold true? What is your answer? Letter C, when A is strictly an element of B. Our test 2, we have here the answers. Well done, everyone! So we're now done with our evaluation. And for your assignment, you may do an advanced study of the action of choice.
Everyone, this is again Teacher Famela Sora,
Teacher Daniela Ebol.
Teacher Faith. Thank you for watching and see you again next week, only here on our channel. Bye-bye!